During these TreeHacks, our team came in extremely excited to test some of the latest generalizable robot policies, such as Pi 0.5, Open VLA, and Small VLA on this very affordable SO101 hardware that we printed out and assembled based on an open source platform that has been being popularized by Hugging Face called La Robot. And in the process of testing these on the many different forms of compute we have, including the DGX Spark we have up here on the chair, as well as experimenting with an Aura Nano, we wanted to see how these generalist robotics policies would perform, as well as how they would perform on edge hardware and any potential applications they may have. During this challenge, however, we found that there are several key modal failures in many of these training policies, especially within a small amount of training and fine-tuning samples. And at the same time, we actually also developed a parallel system that uses Cosmos and runs on the DGX Spark, as you can see, monitoring the deployed policies that we're running on the laptop behind you right here. And in that, if you look at the actual video happening here, that video is currently being streamed into a raw system that we have been using and developing to give us the ability to autonomously oversee the evaluation of these models and also identify common notable failures. For example, the orchestrator behind us here, which has the ability to reason and have long-running tasks planned for a VLA in the future, and we envision connecting to the VLAs themselves in the future as well, which we weren't able to do within the scope of this hackathon. Those models also have the ability to give us the progress in which the task has been completed, telling us whether a block has been stacked correctly or hasn't, and also the failure mode of the particular model that we're testing, as different models have different failure modes. Pi 0, which we tested earlier in the hackathon, for example, which has continuous actions being deployed, had a failure mode where we would occasionally see freezing every 8 seconds. Whereas with small VLA, which has this discretized motion, is a little bit more twitchy in its actions, but is also, in a way, a little bit ironically more continuous. However, most of these models we've tested, unfortunately, are still unable to achieve the generalist results that we've hoped for. But building the connections between the DGX Spark and our infrastructure here with ROS, and especially using Cosmos, has really opened up this future capability that we believe will help to solve the data problem in robotics in the future.